So we will now deal with the derivation of the second trigonometric formula, which you will recognize is the sine formula, the sine rule, which is a over sine A equals b over sine B, which is equal to c over sine C. A, B and C being the lengths of the sides opposite the angles that are being referred to. We have two situations. We have an acute angle triangle and an obtuse angle triangle. So we're given the triangle ABC with the sides ABC as shown. In the first case, angle C is acute, and in the second case, angle C is obtuse. And we're looking to prove the formula. So we must do a construction first, where we draw the line BD perpendicular to AC, and in this case BD again is perpendicular to AC. If it was to continue out, this line is outside of the triangle, but that's fine. So our proof, we've two proofs running concurrently. In the acute case, you take your perpendicular line, your BD, and divide it by the line side C, which gives you sine of angle A. Okay, so this ties in with your right angle triangle ratios. So sine of the angle is the opposite divided by the hypotenuse. Same with the second formula, or the second situation here, where you're looking at sine of angle C here, and it is BD divided by the hypotenuse, so the opposite divided by the hypotenuse A. The obtuse case is the same. The only thing that's a little bit different is just this bit here. They talk about sine. We're actually dealing with this angle here, okay, but we actually want to talk about the angle that's inside the triangle, so that's where the 180 minus C comes from, because it's a straight line. So then we take our first equation that we've created and our second one, and we divide them by each other. And this division is based on two fractions dividing by each other, and then all we've done is just split them apart rather than having the equals over division signs as well. So if you're not sure of how this turned into this, have a go of dividing fractions by each other, that manipulation. And if there's any further issues, we can discuss them in class. And we end up with this ratio here. We simply then multiply by C, so that would eliminate the C on the bottom, and we would have C sine A over sine C. Again, you can check this longhand in your own time. And then if we divide by sine A, we end up with A over sine A equals C over sine C. If we then go and we draw the perpendicular from C to AB, from line C, from corner C to line AB, we can prove in the same manner that the A divided by B is equal to sine A over sine B, which when we do the same, multiplying by B and dividing by sine A, we end up with the other ratio. So if A over sine A is equal to B over sine B, and on the previous slide A over sine A was equal to C over sine C, we can then say that all three are equal to each other, and therefore we have our sine formula.